What we're covering today is proportionality theorems, talking about proportionality, especially with angle bisectors and parallel lines in triangles. And we're going to see how these proportionalities work out with finding measures and finding lengths. And this here is the last section of Chapter 8. So after today, after we finish covering this here, we are done with Chapter 8. Now, triangle proportionality theorem, we have two here. These two theorems, because obviously, well, we can see that there are two. But really, they're the same theorem going in two different directions. And what the first one says is if a line parallel to one side of the triangle, PU is parallel to QS, intersects the other two sides, then it divides the two sides proportionally. What that's saying is that this line segment over this line segment, RT over RU, is proportional to the other two. I flipped those. So let's actually put some letters to it to make it a little more sense. Let's call X, Y, A, B. And what they're saying is that the proportion from X to A is going to be the same as Y to B. Those distances are going to be proportional. And the reason this works out and the reason that this makes sense is because if two lines are parallel, what do we know about them? They will do what? If two lines are parallel, what happens with them? They're always the same distance apart. They do not intersect, they do not cross. And right, for them not to be able to intersect or cross, that means the distance from one line to the other has to be the same, yes? So if these two lines are parallel, the distance from S to U will be the same from Q to T. And because of the fact that they are proportional, it means that the distance from R to T and R to U, that proportion of those two, will be the same as Q to T and S to U. They will be proportional the entire time. Now that brings us to the other one, which states essentially the other way around. If the two sets are proportional to each other, then those lines have to be parallel. So it's one leads into the other. And that's really what we're going to be using for this here to solve for missing sides. In the diagram, QS is parallel to UT. RS is 4. ST is 6. QU is 9. What is the length of RQ? And we can use this. We can use this proportionality to solve for QR. Because QR's length, X, over 4, is going to be the same as 9 over, is it almost left to right, left to right? Any questions on how we set this up or how we've done any of this here so far? We good with this here? Okay. Now what do we need to do to get X by itself? We can multiply both sides by 4. So here the 4 and 4 will cancel. Giving us X is equal to 9 over 6 times 4. And if we did this out by hand, we would multiply 9 times 4, which would give us 36. Well, 36 divided by 6 is 6. Any questions over any of this here so far? Okay. You ready for the next one? Let's look at this here. So they told us that these two lines are parallel, and we want to find YZ. Now we're given 36, 44, and 35, and they wrote those in for us already, so we don't really have to assign those. But how would we start setting this up? Mm-hmm. Right over left, right over left. We just kind of want to keep those matching up, keep them proportional. So these will cancel out, leaving us with x is equal to 36 over 44 times 35. And again, at this point here, we can type this straight into the calculator. Six three. Yeah. So 6.4 if we round up. $28. Okay, thank you. If we're going out to decimal places. Questions on this here? Are we good with this here? Any other questions on anything we've done so far? All right. So it doesn't always work out that we get whole numbers because we can get decimals. You ready for the next one? So when we look at this here, in the diagram, we do have two lines, WZ and XY, that are parallel to each other. WX is 12, VZ is 10, ZY is 8. What is the length of VW? And again, just like with these here and what we've been doing a lot of with this chapter is we're setting up a proportionality. And what would our proportionality be? X over 10 and 12 over 8. Then we can multiply both sides by 10 because we want to get the value of x by itself. These here will simplify, leaving us with x is equal to 12 over 8 times 10 . Now we can multiply this together in a calculator, or we can do it by hand, either way. If we do this by hand, we'll do 12 times 10, which would be 120 over 8. And if we divide this by 8, it's 115. So this one here worked out nicely. Which is nice. But are there any questions on anything we've done thus far? Any questions on any of this here? Okay. Almost. Next page. Okay. Now what we're doing with this here is we're using these properties of proportionality in kind of a real world, quote unquote, real world situation. On the shoe rack, this here, BA is 33 centimeters. 33. CB is 27. CD is 44. And DE is 25. Explain why this shoe rack is not parallel to the ground. Well, if this was parallel, well, BD and AE should be parallel to each other, yes? Well, if they're parallel, it means that CB over CD should be equal to your CD, CB, AB, and DE, those two bottom ones, yes? Not that the measures are equal, but that they are proportional, yes? So let's see what happens. So 27 over 44 should be the same as 33 over 25. Well, looking at these here, I have a feeling they're not going to be the same. Well, why would that be? Just by looking. There's 27 over 44. Is that going to be greater than 1? No, because if it's going to be 1, the numerator and denominator have to be the what? Same. Because 44 divided by 44 would be 1, yes? So any number less than 44 in the numerator would be less than 1. Well, with 33 over 25, 33 is greater than 25, so this is going to be greater than 1. So let's actually see what the decimals are. 6, 1. Okay. 6, 6. And 33 over...
6,
Okay, 0.6. So since these are not proportional to each other, it means the two lines are not parallel. So that's why the shelf is not parallel to the floor, because these are not proportional. Questions on this here? Okay. So we're going to use diagram 2 again, and we have these measures. And this time we want to explain why it is parallel to the floor. Well, BA is 35. CB is 25. CD is 20, and DE is 28. So it gave us these measures. Now, if we want to say that they're parallel to the floor, well, we would say what? That 25 over what? 20 needs to be the same as 35 over 28. Because if these two sets of fractions are the same, if these two sets of fractions are proportional to each other, it means BD and AE are parallel. Yes? So what is 25 over 20? 1.25. And 35 over 28? 5/4 or 1.25. They're both 5/4 or 1.25. So therefore, because these are proportional, therefore, BD is parallel to AE. And in proofs, an arrow is considered to be therefore. Or it could be a injected, or a, it's not biconditional because biconditional goes both ways, but they can be considered some types of statements, which I'm losing the name of right now. Any questions on these so far? Okay. We're going to take that theorem that we just used a step further, because the way we used it just a minute ago is dealing purely with triangles. Now we can use it with any lines. Given 3 parallel lines intersected by 2 transversals, then they divide the transversals proportionally. Because for any 3 lines, or any 2 lines to be parallel, the distance between them has to be the same. So if we have three parallel lines cut by two transversals, well, the distance between those lines are going to be proportional to each other. AB, C, D. So what we can say is that A over B is going to be the same as C over D. AB, C, D are going to be proportional to each other, just like with the triangles. So it might be helpful to have it as this here so it's a little bit easier to see. So this proportionality will work as well. So this here is very similar to what we did with triangles, except for the fact instead of them meeting at a point, we have three parallel lines. Any questions on this here? Okay, so we're going to see a few examples of working with this here. So in the diagram, angle 1, 2, and 3 are all congruent, which means that these three lines are going to be parallel to each other. Find the distance from H to F between Main Street and South Street. So what we want to find in the end is this overall distance. So we know part of it, we just need to find GH. Because if I can find GH, then we can add it to the 120 to get the overall distance, yes? And that's what we're going to be using that in this parallel theorem, because I know Y over 300 is proportional to what? Or actually, hold up. Not 300. What should it be? 120, yes, is equal to 300 over 150. There's our A to B, C to D. We're always operating on the same line. So any questions on how we got this set up? Okay. So then yes, we would multiply both sides by 120, and these would cancel out. And this Y is equal to 300 over 150 times 120. 240. And so the final answer for this is 360. Because it might be very tempting to say that 240 is the final answer, but 240 only gives us GH. Because if I want to find HF, I have to take 240 and add it to 120. Which would give us our 360. So there was a two-part problem. We had to find the one and then use it to find the other. Any questions on any of this here so far? In the diagram, ADE, BEF, and angle CFG are all congruent. So really they're saying that these three lines are going to be parallel. AB is 30, BC is 12, and DE is 35. Find DF. So again, they're wanting us to find the entire length. But with these proportionality theorems, the main thing I can find first is EF. I can find it first. And then once I find it, I can add it back to 35 to find the overall total. Now, how would we set this up? Is equal to 12 over 30. Y over 35 is equal to 12 over 30. At this point here, we want to get y by itself. Since it's being divided by 35, we would multiply it by 35. So when we multiply both sides by 35, this 35 and that 35 would cancel, leaving us with y by itself is equal to 12 divided by 30 times 35. And we all agree y equals 14? Yes. But to get the actual value that it wants for df, df is going to be 35 plus 14. So df is 49. So the actual length we want is 49. Any questions on any of this here? Okay. We're going to skip on ahead to theorem 8.9. This is the last theorem that we're going to cover today and the last theorem for this chapter. If a ray bisects an angle of a triangle, then it divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So if we have a line segment that bisects the angle, cuts the angle in half, then AD over BD CD. So the side that's cut is going to be proportional to the other two sides, to the two sides of the triangle. So if I have a line that cuts one of the angles, the side that it cuts also, those two lengths are going to be proportional to the two sides of the triangle. And it's always going to be working out that each side that's split corresponds to the side that it connects to. So A and C are going to be on top, B and D are going to be on bottom, or vice versa. They're always going to work together in these pairs. Well, almost. Well, let's look at an example of this because it makes sense when we look at an example. This here is the first example we're going to look at. Yes. Because for us to be able to solve this, we're going to need to know what the length of QR is. And there is one on the assignment where you're going to have to do this step. Because for us to set this proportionality up, we're going to need to know what QR is, RS, QP, and PS. We need to know all four of these lengths to be able to solve. Now, for us to find QR, well, I can take 15 and subtract 9.75. This will be 4, 9, 10 would give us 5. 9 minus 7 is 2. 14 would give us 5. So by doing that subtraction, we can find out that QR is 5.25. And by doing that, we now have all four lengths. To find x. Any questions on this here? So we set this as x over what? It would be 13, because we always have the sides of the triangles are going to connect, and the sides that are split are going to be in the same sets of fractions. Because if we look back here at this theorem, AD over BD, AD over BD, those sides that are split are going to be in the same fraction. ACCB, ACCB, the sides of the triangle are together. And they're always going to go in those pairs. So here the sides of the triangle, x over 13 would go together. Oh, it's going to stay on the floor. Now the other two sides would be what? Over 9.75. Because then we'd have the two sides split. Since x went first, the top part of the triangle, the side that connected to it, the 5.25, would go on top, because they will go together. Any questions on this here before we move on to the next part? Okay, so we're going to multiply both sides by 13, because here the 13 and 13 would cancel, giving us x is equal to 5.25 over 9.75 times 13. And that is it. Any questions over any of this here? Are we ready for the next one? Okay, this one here, they tell us that the angle is being bisected. In the diagram, BAC is congruent to CAD. Use the given lengths to find the length of CD. So why? Now this here, we've gotten all four measures, or at least three of them, and we need to solve for the missing one. So how would we set this up? Y over 18 is going to be equal to 63 over 42. We're going to have it set up exactly like this here. Any questions on how this is set up for what we've done so far? So what would we need to do next to be able to solve for the value of y? All right, we need to get the value of y by itself, so we're going to multiply both sides by 18. As we multiply this side by 18, it simplifies that down, giving us y by itself is equal to 63 divided by 42 times 18. That'd be an interesting calculation if it did work out that way. Any questions on any of this here so far? Do we feel comfortable with all of this here? Yes? Okay. Do we need to see another example like the ones we worked here? No? Okay. Because we had this one here, yes. Because, I mean, we're good with this here. These are the exact same. Do we want to look at this one? No? Okay. Yeah. So how about this one here? Let's set it up and see if this is, because if I were to set this up, because one of the links would be x, like the one we wanted to find. Yes, this is not in the note sheet. Because this would be x over what? Because x would be over this measure here, yes? What is that measure? Well, whatever it is, because x and it add together to be what? 15, yes? Well, if I want to know what this measure is, I have to take 15 and subtract x from it. Because like we did in the first problem, because it told us if we didn't have x, we had, I think it was 9.75 or something like that. We took 15 minus 9.75, and it gave us that other length, yes? But here it doesn't give us that value, it just gave us x. Okay, apparently it's still get that out of the way. So if, move that down just a bit, because we're not given one of those two lengths, we're told x and the whole thing is 15, well, one of them has to be x, this one here, and this other length is going to be x minus 15. Now this is going to equal what over what? 13 over 7. So this here, the fact that they changed that one part, they gave us x and the whole length being 15, it's made the problem a little bit different. It's not that it's made it any harder, it just made it a little bit different. So questions on how we got this set up. So we're good with how this is set up and how this is working so far, yes? Okay. We're going to do, in a minute, we're going to use one word I really don't like using, or a kind of shortcut I don't really like using. Cross, I spelled cross wrong. Cross multiplication, because y'all have done this before. It's talking about proportionalities. And when we use cross multiplication, what we're saying is that I'm going to multiply these two together and those two together. And that's really what we would do for this here. If this would scroll properly. So what we'd have is x times 7x. And here we're going to have 13 times 15 minus x. Now we could have multiplied both sides by the denominators, multiplied both sides by 7 and 15 minus x. And that would get us the same thing. Any questions on this here? Now we can distribute the 13. So we do 13 times 15, which will be 195. So we've got to multiply through by the 13. Now we need to get the variables all on the same side. So we can add 13x to both sides. So 13x plus 7x would be 20x is equal to? And that's it there. So it's still the same properties and same process. We had to add a few more steps to find x. But are there any questions on any of this here? Okay. No questions on any